Hi there, and welcome back to How to Win at Chemistry. In our previous episode, we worked through a basic empirical formula problem using mass percents. In this episode, we'll be finding an empirical formula again for an unknown compound. Rather than using mass percent, we'll use a combustion reaction to help us find the masses of the elements in the unknown. Let's begin by briefly reviewing combustion. In a combustion reaction, we begin with a hydrocarbon, which is a substance that has just carbon and hydrogen. It reacts with oxygen and will give us carbon dioxide and water as products. Ordinarily, you'd be able to balance this reaction without too much trouble. However, this example will be a bit trickier because we don't know the formula of the hydrocarbon. Instead, we'll be given the mass of the products, and we'll have to find the moles of carbon and hydrogen in the hydrocarbon. Our first step will be to convert the grams of carbon dioxide and water into moles, since formulas are always in terms of moles. But since we're really just interested in the carbon and hydrogen, our second step will be to convert moles of CO2 into moles of carbon and moles of water into moles of hydrogen. Once we have the moles of each one, our third step is to reduce the moles to lowest terms, just like in our previous episode. Our final step will be to make sure we have whole numbers, and to make adjustments to our formula if any of our numbers aren't whole. Let's start from step 1, and let's see what we can do. An unknown hydrocarbon is burned in a sealed chamber, releasing 13.2 grams of CO2 and 7.2 grams of water on complete combustion. What is the empirical formula of the hydrocarbon? As before, our first step will be to convert our grams to moles because you need moles to get the empirical formula. To find moles, we just take the masses we were given divided by the molar mass of each substance. To find the molar masses, we'll just need to add up all the total masses of the atoms in each compound. You may remember from our previous episode that carbon has a weight of 12, oxygen weighs 16, and hydrogen weighs 1. Let's find our molar mass of CO2 and then the moles of CO2. For CO2, we have 12 from carbon and 2 times 16 from oxygen, for a total of 44 grams per mole. If we divide our 13.2 grams by that 44 grams per mole, we get 0.3 moles of CO2. Let's now find molar mass and moles for our water. For water, we have 16 from oxygen and 2 times 1 from hydrogen, for a total of 18 grams per mole. If we divide our 7.2 grams of water by that 18 grams per mole, we get 0.4 moles of water. Now that we have our moles of each substance from step 1, our step 2 is to find moles of carbon and moles of hydrogen. We'll take care of carbon first and hydrogen second. To find carbon moles, we simply remind ourselves that each mole of CO2 contains 1 carbon. Simply multiply our CO2 moles by 1, and you'll get your moles of carbon, which is still just 0.3. To find the hydrogen moles, we remind ourselves that each mole of water has 2 hydrogens. Simply multiply the H2O moles by 2, and you'll get your moles of hydrogen, and 2 times 0.4 is 0.8. We'll carry these moles of carbon and hydrogen forward into the next step. Our third step is to reduce our moles of carbon and hydrogen to lowest terms. From the previous step, we carry our 0.3 moles of carbon and 0.8 moles of hydrogen. To reduce to lowest terms, we simply divide both of these by the lowest number. We end up with 1 for carbon and 2.67 for hydrogen. The only problem here is that our empirical formula can only have whole numbers in it, and that decimal is a problem. We'll have to multiply both numbers by something in order to get rid of that decimal. Here's a quick guide about how to change from decimals to whole numbers with a minimum of headache. If your number ends in 0.5, you should multiply everything by 2, since 2 times 0.5 gives you a whole number. If your number ends in 0.33 or 0.67, you should multiply everything by 3. If your number ends in 0.25 or 0.75, you should multiply everything by 4. Those are the multiples you're most likely to see. If 2, 3, and 4 don't work, you can always try 5 or 7, but those are pretty rare. Since our only decimal is a 0.67, let's multiply both of our terms by 3. For carbon, we have 1 times 3 for a total of 3 carbons, while hydrogen has 2.67 times 3, giving us 8 hydrogens. Therefore, our empirical formula is C3H8, or propane. And there you have it. Combustion problems are tricky at first, but this process should work for most of them. Thank you once again for watching, and remember to keep winning at chemistry.